Imagine, for a moment, the morning after the unthinkable. Deep beneath Yellowstone National Park, in the vast chamber of molten and half-molten rock that has slumbered quietly for hundreds of thousands of years, something finally gives way. The ground heaves, the earth splits, and one of the most powerful volcanic events the planet can produce begins. Within hours, a towering column of ash and rock blasts 30 to 50 kilometers into the sky, far higher than any airplane flies, and a colossal cloud begins to spread outward across the North American continent. This is the scenario that has haunted the public imagination for years. The Yellowstone supervolcano finally waking up. But before we go a single step further into this dramatic thought experiment, one thing must be said loudly and clearly, because this subject is drowning in myth and misinformation. What you are about to hear is a scientific thought experiment, an exploration of what would happen if this extraordinarily unlikely event ever occurred. It is not a prediction. It is not a warning of imminent doom. Yellowstone is not, despite what you may have heard, overdue to erupt. With that firmly established, let us explore, using real science, what would actually happen the day after Yellowstone wakes up, and which cities would be the first to vanish beneath the ash. Let us start by dismantling the fear, because the truth is genuinely reassuring. And you deserve to hear it before we indulge in the disaster scenario. The United States Geological Survey, which monitors Yellowstone more intensively than almost any volcano on Earth, estimates the annual probability of a super-eruption at roughly 1 in 730,000. To put that in perspective, you are something like 40 times more likely to be struck by lightning in a given year than to witness a Yellowstone super-eruption. The popular claim that Yellowstone is overdue is simply false, a myth born from a basic misunderstanding of statistics. People take the three great past eruptions, which occurred roughly 1 million, 1.3 million, and 640,000 years ago, average the gaps between them to get a figure of around 700,000 years. Note that the last one was 640,000 years ago, and conclude we are due. But volcanoes do not run on schedules or calendars. The intervals between those eruptions were wildly irregular, and there is no clock ticking down. Even more reassuring is the state of the magma itself. The chamber beneath Yellowstone is currently only somewhere between 5 and 15% molten liquid rock. The rest is solid, crystalline mush. To produce an eruption, let alone a catastrophic one, you would need a vast volume of mobile, molten magma, and that simply does not exist beneath the park right now. Building towards such a state would take many thousands of years and would announce itself with unmistakable warning signs. It is also worth clearing up a related misconception that fuels a great deal of needless anxiety: the idea that recent earthquakes or steam explosions at Yellowstone are signs that the big one is coming. Yellowstone is a seismically active place by its very nature. It experiences thousands of small earthquakes every year, the vast majority far too weak to be felt, and this constant gentle rumbling is completely normal and expected. Swarms of small quakes come and go regularly and are not harbingers of an eruption. Similarly, the park occasionally produces hydrothermal explosions, sudden bursts of steam and rock driven by the superheated water in the ground, and while these can be locally dramatic, scientists are clear that they are not warning signs of impending volcanic doom. In fact, this ordinary background activity is part of what makes Yellowstone such a spectacular and dynamic landscape, driving its famous geysers and hot springs. The mistake people make is to interpret this normal, healthy restlessness as a countdown, when in reality it is simply the ordinary breathing of a geologically active region, one that has been breathing the same way, harmlessly, for as long as anyone has been keeping records. And this is the final piece of reassurance, perhaps the most important one. If Yellowstone were ever genuinely moving toward a major eruption, we would almost certainly see it coming, and not subtly. The system would announce its intentions through a dramatic and prolonged escalation of warning signs, swarms of increasingly powerful earthquakes, rapid swelling and deformation of the ground as magma pushed upward, and significant changes in the heat and gases venting from the surface. These signals would build over a long period, likely months, years, or even longer, giving scientists and authorities time to understand what was happening and to act. Yellowstone is blanketed with seismometers, GPS stations, and satellite monitoring that can detect ground movement down to the millimeter. It is, in a sense, one of the most closely watched patches of ground on the entire planet. The millions of people who visit the park each year face no volcanic risk whatsoever. The real dangers there are the scalding hot springs, not the sleeping giant below. So as we now turn to imagine the catastrophe, hold on to this, we are exploring a scenario that is real in its physics, but vanishingly unlikely in our lifetimes, and one that would not strike without ample warning. With all of that firmly in mind, let us now indulge the thought experiment fully, because understanding what a super-eruption would do is genuinely fascinating and reveals the immense forces sleeping beneath our feet. A supervolcano, by definition, is one capable of an eruption that ejects more than 1,000 cubic kilometers of material in almost incomprehensible volume, placing it at the very top of the scale that measures volcanic explosivity. Yellowstone has done exactly this 3 times in its distant past, and each time fine volcanic ash blanketed much of the western half of North America. So we know it is possible because it has happened before, long before any humans were around to witness it. The question we are exploring is simply this. If it were to happen again today in our modern, densely populated, deeply interconnected world, what would the aftermath actually look like, beginning in the very first hours and days? In the immediate vicinity of the eruption, within roughly the first 60 to 100 miles, the devastation would be total and would come not primarily from ash, but from something even more violent, pyroclastic flows. These are the true monsters of a large eruption, avalanches of superheated gas, molten rock fragments, pumice, and ash that surge outward from the volcano at speeds that can exceed 100 miles per hour at temperatures of many hundreds of degrees. Nothing survives a pyroclastic flow. It incinerates and buries everything in its path, flattening forests, obliterating structures, and scouring the landscape down to bare rock. The parts of Wyoming, Montana, and Idaho closest to Yellowstone would be subjected to these flows, and Yellowstone National Park itself, one of the most beautiful places on Earth, would simply cease to exist as we know it, replaced by a smoldering, lifeless expanse. This innermost zone of total destruction would be rendered utterly uninhabitable in a matter of minutes to hours. To picture the sheer violence of this, it helps to understand what a pyroclastic flow actually is at ground level. It is not lava in the slow, glowing, oozing sense that most people imagine when they think of a volcano. It is a ground-hugging hurricane of incandescent gas and rock, dense and fast and utterly unstoppable, that behaves almost like a fluid as it races down slopes and across valleys, following the terrain. Because it is heavier than air and moving at highway speeds, there is no outrunning it and no sheltering from it. It fills every low spot, pours over every ridge, and turns the landscape into a furnace. In the great eruptions of the past, these flows from Yellowstone traveled tens of miles from their source, laying down thick sheets of welded rock that geologists can still study today. Anyone and anything caught within this zone would have no chance of survival, and there would be no meaningful way to rescue or recover from it afterward. It is the reason the innermost region around the park is spoken of not in terms of damage or disruption, but in terms of complete annihilation, a place simply erased from the map in the opening act of the catastrophe. Beyond the reach of the pyroclastic flows, the primary threat becomes the ash, and here is where a super-eruption behaves in a way that is genuinely different from an ordinary volcano and far more dangerous over a wide area. A normal volcanic eruption sends up a plume that then drifts downwind, dropping most of its ash in one direction. But a super-eruption is so powerful that it creates what scientists call an umbrella cloud, a colossal canopy of ash that spreads outward evenly in all directions, pushing against the wind rather than simply following it. This means the ash does not just blow one way, it radiates outward across the entire surrounding region, blanketing everything and gradually thinning with distance. The cities and towns closest to Yellowstone would find themselves buried under the deepest, heaviest accumulations of ash, and they would be buried first, within the initial hours and days of the eruption. So let us identify which cities those would be, the ones that would bear the earliest and most crushing weight of the fallout. The first and most obvious is Billings, Montana, the largest city in that state and one of the closest major population centers to Yellowstone, lying to the northeast. Scientific modeling has specifically identified Billings as a place that could be buried under anywhere from several centimeters to more than a meter of ash. That is, more than 3 feet of heavy, choking, gray debris. A city buried under that much volcanic ash would be, for all practical purposes, paralyzed and largely destroyed. The second is Bozeman, Montana, which sits even closer to the park, just to its north. Its proximity would place it squarely in the path of heavy early ashfall and quite possibly within reach of the eruption's most violent effects. The third is Idaho Falls, Idaho, lying to the southwest along the ancient track that the Yellowstone hotspot has carved across the landscape over millions of years. It, too, would be among the first communities to disappear beneath a deep gray blanket. The fourth is Jackson, Wyoming, the resort town nestled just south of the park, practically on Yellowstone's doorstep, which would be one of the very nearest communities to the eruption itself and among the first overwhelmed. The fifth city on this grim list is Casper, Wyoming, lying to the east and, like Billings, specifically identified in scientific modeling as a place that could receive more than a meter of ash. And just beyond these five. Other significant cities would be heavily affected in short order: Cheyenne, Wyoming, Salt Lake City, Utah to the southwest, Rapid City, South Dakota to the east, and many smaller communities scattered across the northern Rockies and High Plains. It is worth being honest and precise here, the exact pattern of which cities receive the most ash, and in what order, would depend heavily on the specific conditions of the eruption, including the prevailing winds, the height of the ash column, the duration of the eruption, and the size of the ash particles. The umbrella cloud spreads ash in all directions, but winds still shape the distribution, so the precise map would vary. What is not in doubt is that the ring of cities closest to Yellowstone, the ones we have just named, would be the first and hardest hit, buried while much of the rest of the continent was only beginning to see the sky turn gray. Now, why is being buried in ash so catastrophic? Why does it warrant the dramatic word buried at all? Because volcanic ash is nothing like the soft, fluffy ash from a campfire. It is, in reality, pulverized rock and volcanic glass, tiny, jagged, abrasive particles that are genuinely heavy, especially when they become wet with rain. Just a few inches of accumulated ash is enough to cause roofs to collapse under the weight, and a burden of more than a meter would flatten the majority of ordinary buildings, crushing homes and businesses across the affected cities. But the destruction of buildings is only the beginning. That same abrasive ash would choke and destroy the engines of cars, trucks, and machinery, grinding transportation to a halt. It would render air travel across a huge swath of the continent impossible, as ash is deadly to jet engines, grounding flights far beyond the region actually receiving heavy fallout. It would clog and contaminate water supplies, short out electrical grids and transformers, and blanket farmland in a toxic layer that would smother crops and kill livestock across some of the nation's most productive agricultural land. The weight problem deserves special emphasis because it is the mechanism that would do the most to physically bury and destroy these cities. Dry volcanic ash is already dense, far denser than snow, but the real danger comes when it rains, as it very often does during and after a large eruption because the ash cloud itself seeds precipitation. Wet ash can weigh roughly twice as much as dry ash, turning an accumulation that a roof might have barely survived into a crushing sodden load that brings the entire structure down. This is why in the historical eruptions that have buried towns, so many deaths came not from the ash in the air, but from roofs collapsing onto the people sheltering beneath them. Across the buried cities, this same grim process would play out on a massive scale, with homes, schools, hospitals, warehouses, and shopping centers giving way one after another under the accumulating weight. And unlike snow, ash does not melt. It does not evaporate or wash away easily. It simply sits there, an inert, heavy, abrasive shroud that would have to be physically shoveled and hauled away by the millions of tons. A cleanup operation of a scale and difficulty almost beyond imagining in cities where the machinery needed to do the hauling had itself been destroyed by the very same ash. The effects on human health and on the basic functioning of society would be severe and immediate. The fine particles of volcanic ash, when inhaled, cause serious respiratory distress, and the sheer darkness would be disorienting and terrifying. In the areas of heaviest fallout, the ash cloud would blot out the sun and turn day into an eerie, choking night. As the ash accumulated, it would make roads utterly impassable, cutting off the buried cities from the outside world and hampering any attempt at rescue or evacuation. Power would fail, water would become undrinkable, communications would break down, and the millions of people living in the affected region would face a sudden and near total collapse of the systems they depend on to survive. The immediate aftermath in the buried cities would be a desperate struggle amid a gray, silent, and profoundly hostile landscape, one that would require an evacuation and relief effort on a scale never before attempted in the nation's history. But the consequences of a Yellowstone super-eruption would not stop at the borders of the buried region. The ash would continue to spread across the entire continent, thinning as it went. Cities in the upper Midwest, like Minneapolis and Des Moines, would receive centimeters of ash, enough to cause serious disruption. Even distant cities on the east and Gulf coasts, like New York and Washington, would see a measurable dusting, millimeters of ash settling over everything. The nation's air travel, agriculture, and supply chains would be thrown into chaos from coast to coast. And then there is the most far-reaching consequence of all, the one that would affect not just North America, but the entire planet: the climate. A super-eruption would inject enormous quantities of ash and sulfur gases high into the atmosphere, where they would linger and spread around the globe, reflecting sunlight back into space. The result would be a measurable drop in global temperatures, potentially by several degrees, lasting for years. This volcanic winter would disrupt growing seasons worldwide, potentially triggering widespread crop failures and a global food crisis. An eruption in Wyoming could, in this way, cool the entire planet and threaten harvests on the other side of the world. History offers a sobering, if far smaller, preview of this effect. When the volcano Tambora erupted in Indonesia in the early 19th century, an event vastly smaller than a Yellowstone super-eruption. It cooled the globe enough to cause what became known as the year without a summer. With snow falling in June across parts of the northern hemisphere, failed harvests, and widespread hunger thousands of miles from the volcano itself. A full Yellowstone super-eruption would dwarf Tambora many times over, and its climatic shadow would fall across every continent. The interconnected nature of modern civilization, with its global supply chains and just-in-time food distribution, might make us more vulnerable to such a shock than our ancestors were, not less. A few years of failed harvests across multiple continents all at once would test the resilience of the entire global food system in ways that are difficult to fully predict. Which is precisely why scientists study these rare events so carefully, even knowing just how unlikely they are. Having journeyed all the way to the edge of global catastrophe, it is now essential to travel back to reality and plant our feet firmly on solid, reassuring ground, because the responsible thing to do is to end not in fear, but in perspective. Everything we have just described is a genuine possibility in the sense that the physics are real and it has happened in the deep geological past. But it is critical to remember just how staggeringly unlikely it is to happen in any human time frame. That figure of 1 in 730,000 per year bears repeating. The magma chamber, as we noted, is not currently in a state capable of producing such an eruption, and getting there would take an immense span of time and give clear escalating warnings along the way. Furthermore, and this is a point often lost entirely in the sensational coverage, a super-eruption is actually the least likely thing Yellowstone will ever do. If Yellowstone becomes volcanically active again at all, the far more probable event by a wide margin is a smaller lava flow or a hydrothermal explosion driven by its underground water and steam. Events that would be locally hazardous, but nothing remotely like a continent-altering catastrophe. The doomsday scenario is the rarest of all the possibilities. So why do we find this subject so endlessly fascinating if it is so unlikely to affect us? Perhaps because it connects us to the awesome, humbling power of the planet we live on, a reminder that beneath the seemingly solid and permanent ground lies a dynamic, restless world of heat and pressure and slow, immense forces. Contemplating what Yellowstone could do, even knowing it almost certainly will not do it in our lifetimes or our children's or our distant descendants, gives us a healthy respect for the geological forces that have shaped our world and a genuine appreciation for the scientists who watch over these sleeping giants so vigilantly. The very fact that we can estimate these odds, model the ashfall, and monitor every tremor is a triumph of human understanding, and it is precisely that watchfulness that allows the rest of us to sleep soundly, untroubled by the giant beneath the geysers. So, what happens the day after Yellowstone wakes up? in the almost unimaginably rare event that it ever does so with a full super-eruption? The answer is that the cities nearest to it, Billings, Bozeman, Idaho Falls, Jackson, and Casper, would be the first to vanish beneath a suffocating blanket of ash, followed by a continent dusted in gray and a world plunged into a cold and hungry few years. It is a genuinely sobering scenario to contemplate. But the far more important truth, the one that the actual science insists upon, is this: tomorrow morning, and almost certainly every morning for many thousands of years to come, Yellowstone will do exactly what it has done every single day for the last 640,000 years. It will steam gently, it will spout its geysers on schedule, and it will otherwise sit quietly, doing nothing at all. Watched over by the most sophisticated volcano monitoring system on the planet. The day after Yellowstone wakes up is a thrilling and terrifying thing to imagine. But for you and for everyone you will ever know, it is in all likelihood a day that will simply never come.